Okay, great. So it's just about 7 o'clock, so I'd like to go ahead and get started with some introductions and welcome everybody to our information session. Really appreciate you taking the time to be here tonight and learn a little bit about the proposed project that we are in the early stages of planning. My name is Josh Arnold, and I'm an employee with the UW-Madison Office of Sustainability. And part of my job is to find opportunities for our institution to help further our mission through innovative projects like the proposed project that we are going to be talking about tonight. So it's a project that I'm very excited about and excited to share some information and talk with and have the project team share some information as well. So we have, I'll start with some introductions, and then we have some information from UW-Madison, and then information from Alliant Energy and Sunvest, our solar contractor. So I will go ahead and make some introductions. On tonight's call, we're very fortunate to have representatives from all of the project team. We have Gary Brown, the Director of Campus Planning and Landscape Architecture at UW-Madison, and he'll be sharing some information about the project and where it's located and what it is and what it isn't and things like that. We're also very fortunate to have Bob Paulos with us. Bob is the director of the Physical Sciences Lab, which is located at the Kegonsa Research Campus. And we also have several other folks from UW-Madison, and I would be remiss without starting by thanking Lori Wilson, who's here with us, who has set up this, this program for this evening. We also have several representatives from Alliant Energy, and speaking tonight will be Chase Coleman, one of the communications partners with Alliant Energy. After Chase, we'll have John Daugherty speaking, and he's a VP with Sunvest Solar, the solar developer for the project. So on this screen, you can see that we have a number of different organizations and units at UW-Madison that have been working together to put some early planning together for this project, along with our project team. Gary, I'll hand it over to you to share a little bit of information about the location of the project and some of the context that we'll be talking about.
Great, thanks, Josh. As Josh introduced me, I'm Gary Brown, Director of Campus Planning, Landscape Architecture, and Facilities Planning Management here at UW-Madison. Been working with Josh and the team in Office of Sustainability, as well as our partners at Alliant and Sunvest for the last several months, and looking at the early planning stages of a new solar array, small cell solar array down in our Kegonsa Research Campus. Just west of Lake Kegonsa, as you can see there on the map. Many of you on the neighborhood probably know that this site has been used by our Physical Sciences Lab for a variety of programs related to supporting research on campus. And we still have many acres out there that are in agricultural production that we lease out to a local farmer. So if you go to the next slide, Josh. Just zoom in a little bit, you can see on the left-hand image, the Kegonsa Research Campus site is outlined in black. There's several blocks there, but the main campus there on Schneider Drive, you can see. And the yellow box is showing the approximate location of the new 2.25 megawatt solar array that we're planning on about 10 acres or so. You'll see that it's sort of basically southwest of the main complex of buildings. We selected this site in particular because it's off the road. It's also a little bit downhill from the road. It's also in an area that we know has some prime agricultural lands, but a lot of it is actually not classified as prime agricultural land. So following some of the information that we've received from the town of Dunn and their draft solar array ordinance, and trying to again continue to make sure we're following the town comprehensive plan as well as Dane County plans related to land use. We again tried to site this solar array in an area that would not impact agricultural lands. But we'll talk a little bit tonight about how we're actually going to combine the solar array with agricultural research. So Josh may get into a little bit about what we call agrivoltaics and how we mix the solar program with continuing agricultural research. It's an exciting new area that we're looking into on campus. We have lots of faculty very interested in it, but it's one way of continuing the agricultural purposes of the land under and around the solar arrays. And we'll get into that in a little bit. On the right-hand side, you can see it a little bit better. It's in, a little bit zoomed in. It's also a nice color aerial. And you can see the solar array panels sited down on the site there, again, downhill from the main campus. Sort of as you go down the slope towards the creek and the watershed that's down there. The site is outside of the watershed, outside of our floodplain boundaries. Again, taking cues from our friends of the town of Dunn and Dane County about siting this particular solar array. Next slide. So this is a small scale solar array project on about 10 acres of our overall 280 acre Kegonsa Research Campus. As I mentioned, this will be combined with agricultural research in what we're calling agrivoltaics. This obviously supports our overall university mission for teaching and research. And we already have obviously lots of research going on at the Physical Sciences Lab in our Kegonsa Research Campus. But this is another way to have the university support the Wisconsin idea and really getting the idea of research out into the communities and supporting new technologies across the state and really helping the state improve in the technologies. It clearly has some economic development potential for it and provides revenue to the local government and allows the university to advance our sustainability initiatives. We did cite, as I mentioned, the solar array in an area that tries to minimize the views from the surrounding properties and roads. If you'll be with us in a couple of weeks on March 24th, when we talk about our environmental impact assessment that has been drafted, we'll show you some renderings and some images from those views along Schneider Drive and along Green Road so that you can see the impacts of that. Again, as I mentioned, this does avoid prime agricultural soils where possible. And again, the environmental impact assessment has been drafted. You may have received already notifications related to that meeting, but our consultants from AIRS will be doing a presentation on the draft environmental impact assessment on March 24th. Next slide. So we've talked about this combination of agricultural research and education. I think that's really an important piece to all of this. Really understanding, how can we just not put a solar array out there, but actually look at how can we indeed combine this with agricultural research. And it may be more than just planting native plants in these areas. We know in some other solar locations, like at the O'Brien site in Fitchburg, there actually are prairie plants planted in and around those solar panels as well. But we really want to spend a little bit more time digging into that. How can we use this site for agricultural research? How can we look at stormwater runoff, which is also another issue, soils analysis, what happens when you do plant prairie plants, but what happens if you plant crops or other types of things that you actually could continue to harvest off those lands in and around the solar panels. What does that do for water quality research, pollinator habitat, microclimate studies, and then of course using potentially even small stock animals around to help us manage that vegetation. So there's lots of very interesting potential for research here. And again, as I mentioned, we have faculty in our College of Ag and Life Sciences, as well as faculty in engineering, landscape architecture, urban planning. A variety of faculty around the campus are very interested in participating in potential research at this site. Next slide. So project timeline. We've been beginning our community engagement here in the winter of 2022. We'll continue that here for the next couple of months. We do have some permitting coming up and preliminary design work that'll lead into the summer. And hopefully in early April, we'll receive approval of our lease through the Board of Regents. That's the first or second week of April. That'll allow us to design and go through the permitting process through the conditional use approvals through the town of Dunham as well as up to Dane County. So that'll happen through the summer and into the fall, winter of 22. So later this calendar year and into early next calendar year, we'll continue our final designs and interconnection process. The interconnection design and procurement will happen in late winter and into early 2023. That's the process of actually connecting the solar array into the overall grid. And we'll talk a little bit about that here coming up as well. With final permitting in spring of 2023, basically a year from now, start construction then in spring and have most of the work done by summer of 2023. Will be all put online at that point. So as I mentioned, we do have a draft environmental impact assessment process underway. Ayers Associates is helping us with that. They're a third-party engineering firm. Ben Piotr is leading that team in his office. And this is something actually we've decided to do because this is Board of Regents property. We're actually required to do an environmental impact assessment. But because this project is being led by Alliant and others under a lease arrangement, we still thought it was important to do an environmental impact assessment. So again, on March 24th, 7 p.m., we'll have another virtual meeting to share the results of that draft environmental impact assessment and take public comment on that. The draft environmental impact assessment will be released at least a couple of weeks ahead of that. So I think coming up here in the next week or so, the draft will be posted. We do have legal notices out in the local papers, and it will also be available at the local libraries, both in McFarland and in Stoughton. There will be online information as well. You see a website down there, Ayers Project Info. There will be a web link that can take you right to the draft environmental impact assessment as well. Next slide. I think we'll turn it over to our friends at Alliant, and I believe that's Chase.
That's correct, Gary. Thank you so much. And yeah, as Josh kind of mentioned, my name is Chase Coleman. I'm the communications partner at Alliant Energy, working on the solar development and many others that we're working on currently, just to like this one. I'd like to just give a little bit of background really about Alliant Energy and what kind of brought us together in partnership with UW-Madison. And that really kind of stems from in 2019, we announced our Clean Energy Blueprint in Wisconsin. And yeah, like it says, it's really just our roadmap for accelerating our transition to cleaner renewable energy. And really what that means is just adding renewable energy resources, such as solar, along with battery and wind, while also retiring coal from a generation fleet. And Josh, if you move to the next slide, you can kind of see how we're going to do that. So kind of built within our Clean Energy Blueprint for Wisconsin, we have these goals of sustainability that Alliant Energy strives to and commits to. That includes adding nearly 1,100 megawatts of solar generation in Wisconsin. We expect to do that and plan to do that by the end of 2023. And that number of 1,100 megawatts is enough to power just about 250,000 homes in Wisconsin. So it's a really important thing for our customers and just really moving forward that renewable energy commitment. Along with that is that reduce in carbon emissions from the electricity we generate. And by doing that, we expect to reduce that by 50% by 2030. And that overarching goal of achieving net zero emissions by 2050. And along with that, we plan to eliminate all of our coal from our generation fleet by 2040. And again, like I mentioned, doing that will be by adding solar, battery storage, and wind resources to our generation fleet. And you can skip ahead there, Josh. And really what brings us together with UW-Madison and how we're making this possible is our customer-hosted renewable program. This is a program that we have at Alliant Energy that we really partner with our customers and different organizations within and around our service territory that allow them to, achieve these renewable and sustainability goals that they have by doing what we're doing here, by leasing land, whether it be land or rooftop. We work with a lot of different entities, and allowing Alliant Energy to install solar panels on that property. Once that solar garden is constructed, as obviously we're using SunVest to contract that out, that energy goes right back to the grid. And the organizations and customers that take advantage, like UW-Madison will be doing, they will get lease payments on an annual basis, or if they want, they can receive RECs, renewable energy credits, in lieu of a lease payment. And if you go ahead, Josh, we can kind of see how that works. And really, I'll skip down to that bottom there. What a REC means is really that helps kind of achieve that sustainability goal by installing solar or renewable energy resources on a property. They get that back and they can show kind of them doing that and kind of drawing that out in a good way. There's lots of different benefits from doing this, and this is why we work with UW-Madison in different groups. It can help turn unused space or maybe underutilized space into income for not only the organization, but the community around them too. By doing so and installing solar arrays, they get that monthly lease payment or those RECs by doing so. And it also it goes and showcases green leadership with that community. That generating positive goodwill with the customers and community goes a long way. And that's really what we strive for at Alliant Energy, to partner with these organizations like UW-Madison in installing these renewable energy resources. I think that's it from Alliant.
Wonderful. Thank you, Chase. And this next topic here might be something that maybe Andy from Alliant could speak to briefly, or John from SunVest. We have you queued up next, John. But Andy, this is our slide about the proposed interconnection and also the proposed construction roadway for the project.
Yeah, absolutely. Hello, everyone. My name is Andy Ehlert. I am a resource development project manager with Alliant Energy, and I am also the program director for customer hosted projects. And like Chase said, this is a project that is being modeled under the Alliant Energy customer hosted tariff-based program. And as you can see, a big component of this project, not only with the solar array on the site itself, is the interconnection. And the interconnection is the circuit and the fiber optics that will run basically from the solar array to the north and connect to our closest project substation. Yeah, so move your cursor. Actually, we'll go to the left screen. We'll start there with, yes. So the red there is showing our approximate location of an access road. And it's going to be an engineered access road, gravel most likely, engineered. Sometimes those projects can have a grass covered roadway, but I think our preference will be to actually have it engineered with a gravel layer. Alongside of that, we will have the beginning of what we would call our electrical distribution interconnection line. That's actually comprised of two different items. One is electrical, buried electric, and then also fiber optic. And they will both run in generally the same trench, maybe several feet apart. It will follow up to the road there. And now we most likely will probably go under that road and then follow that road to the east over to the intersection of Dyerson Road. Yep, right where your cursor is, correct. Following that to the north, we would probably go underneath what is UW actually has their own 3-phase on the west side of Dyerson Road. We will probably be buried underground through that stretch up to County Highway B, in which then there's a couple of different options there, and we have not quite gotten far enough into design to really know where we're going to go. We could go east at that point of County Highway B, or we could continue north. But ultimately, and there's a couple different options there. We could go above ground. Most likely we'll be continuing that, going underground all the way up to Highway 51 there, and then continuing all the way up to the substation. That's an Alliant-owned substation, and that's where we would be interconnecting the solar array.
Andy, thank you very much. Really appreciate that. Our next set of slides are from Sunvest, and we've got John on board to talk a little bit about the role of the solar developer in this project. We've got about 5-10 more minutes of slides, and then we will open things up for discussion. And so if you have any questions, you can please go ahead and start putting those in the chat. And we'll make sure that we address them when we get to questions and discussion after John. So John, you're up.
Thanks very much, Josh. My name is John Doherty, as was mentioned. I'm the Vice President of Project Development at Sunvest Solar. We're a Pewaukee-based solar development company, so that's about 70 miles or so to the east of the project site, with an office in Madison. So we're a local group, so happy to be doing solar projects within Wisconsin, of course. Our role in the project is, as you see on the screen here. So we basically will handle the technical design of the solar system itself, and then the procurement of the solar equipment and construction of the array. And then, in partnership with Alliant, of course, who's going to be the owner of the array, work through the interconnection design process, as Andy previously outlined. A couple points just to work through where we are in our design currently. So we, of course, are always citing projects as best we can to minimize impact. And as you can see here, we've done preliminary analysis on the site. So it's out of floodplain. And as Gary mentioned earlier, we're trying to target a kind of minimal impact, non-prime agricultural land as well. We'll continue to this diligence as the project continues. Here's another view, preliminary findings. There's also no wetlands on the site, so neither floodplain nor wetlands. We can go to the next slide. As mentioned previously, but I think worth reiterating, this concept of agrivoltaics is a certainly exciting one for someone, myself, UW graduate in biology, and very excited to bring together not only a solar system, but also using agricultural, the land for what it's continued to be used now. So what we're going to explore is possibilities of various items. So one would be increasing the racking height so that it's the system holding the modules to a taller height, which would allow either crops to grow underneath or livestock to roam. There'd be some benefits there, of course, to minimize typical maintenance for a system, as well as have a dual use in kind of an agricultural yield. So here are our design goals laid out, and I think these were covered as well by Josh, but we want to, I guess, two things I want to touch on. We, of course, want to comply with all regulations, but a typical question we'll get from surrounding interested partners is kind of what to expect from an array itself. One note here, we have designed to avoid glare, and that's one we want to make sure we touch on. So the system solar modules are designed to absorb sunlight and turn that into electricity. So that combined with an anti-glare coating really does minimize any glare you'll find from the array. Here's a list of kind of common questions we get, which I think are worth noting and leaving here for further review, and hopefully can help answer some of the questions. So right now the system is designed as a fixed mount solar array. which means there are no moving parts. So at night, specifically when the inverters are off, there'll be absolutely no noise coming from the system. During operation, during daylight hours, you'll get a slight hum from the fans cooling the inverters, but the very quiet system, especially in its location, not close to any other parties. The traffic generated here, that note, basically want to cover that there'll be construction of the array, there'll be some construction traffic, but following that, during regular operation, there's no interaction. It's going to be remotely monitored. If service is needed, and basically twice a year there'll be inspections. It just would be a truck rolling to site, and very minimal impact to the surrounding area. One other question I think at the bottom here I just want to touch on, because it is one that comes up very frequently in any project build of this type, are lighting concerns. There is no lighting for the system, so at night it will not change the layout of the field at all. A couple other questions we want to just try to make sure we're answering. We're going to control water during the course of not only construction, but of course after construction during the 25-year lifespan of the array. And as I mentioned previously, the most operational maintenance is going to start with remote monitoring, so minimizing the impact and the amount of people that have to be on site during its entire operation. Couple other points on construction. So here is an image of an array being constructed in its early stages. So these are rammed I-beams that are pile driven into the earth. So there's no additional concrete holding the structure into the ground. And at the time of the completion of the project, that steel can be removed and the land be returned to its previous state. So the I-beams are going to be designed. So based on the geotechnical analysis that is yet to be done, that will set the depth that the piles need to be pushed into the ground. And from there, the racking system will be built and the modules placed on top. So there's two things. There'll be the racking height, as I mentioned previously, depending on what agricultural additional use we come up with. And then also the spacing north to south of the various rows of modules. So that the row to the south doesn't shade the road to the north. So that'll be set by the angle of the modules. Again, in final design will be completed based on the other use of the site. And finally here, we just wanted to list this pollinator habitat and seed mix. So this is a kind of baseline level for agrivoltaics that we would propose would be to have native pollinator habitats and better water control using native seed mixes that can establish a prairie on site. So that's there as a list.
John, thank you so much for your description. Really appreciate all of that information. We are getting towards the end of our presentation. We'll open it up for questions, discussion next. Before we do, just wanted to put in just sort of another reminder. Gary had shared information about this already, but just wanted to make sure people had on their radar. I guess 2 weeks from tonight at 7 p.m. it'll be a virtual meeting. Our consultants at Ayers Associates will be reviewing the draft environmental impact assessment report. So that's tonight, or 2 weeks from tonight, March 24th at 7 p.m. Also wanted to let people know that we have a landing page on our website with additional information about the proposed project. We invite you to look at that website for additional information, or we will have our contact information as well to share. In fact, here it is. Here's our contact information if you have any specific questions. My information is on the left there, Gary's information on the top right, and then Chase and John as well. So that is our presentation tonight. We want to thank you for being here and want to now open things up for any questions about the project and discussion. So let's see if do we have anyone with questions? Lori, maybe I could ask for your help here because I can't see if people are raising their hands.
I can help with that. I don't see any chats or any raised hands yet.
And I would encourage folks to go ahead and type your questions into the chat. That's a great way for us to make sure we capture your question and can follow up. Questions about the scope of the project, timeline. I think we've gone through a lot of this. Any concerns or any thoughts that you might have about problems or concerns we might hear from the town of Dunn, the residents in the area? Ben, any particular questions or comments from your perspective?
No, I think the presentation was very good. So thanks for going over all of that. I haven't heard from anybody in the neighborhood yet about it, but I will certainly collect any responses that I get.
Great, thanks for being here tonight.
Thank you, Ben. Great. Well, we will hold on for another few minutes. We can be here online in case anyone has any other questions that come up. Otherwise, what we'll do is we will once we finish up this recording, we will post this to our website that I referred to earlier. So we'll have that available in case anyone wasn't able to attend tonight but wanted to learn the information. And again, we'll have that environmental impact assessment talk in 2 weeks when Ayers Associates will go over the draft findings from their draft environmental impact assessment. Wonderful. Well, if there aren't any other questions, again, we thank you very much for your time. And again, we are very excited about this project. It's an innovative agrivoltaic project, and we've talked a little bit about the potential benefits to our institution. We're very excited about this project, and we really appreciate your time and interest in dialing in. So we will go ahead and conclude our presentation for tonight. Thank you.